Hello, boys and girls. This is Ms. Contreras here with your first math review lesson. So from now until the end of this year, me, Ms. Kennedy, and Ms. Walsh are going to be doing review lessons. So these are lessons from this past year that we've already done, but that we want to make sure we go over and have you guys do more practice on so you're ready for 6th grade next year and you have these things mastered. So the first review lesson we're starting with this week is Chapter 2, Lesson 1, which is prime factorization. So a reminder about prime factorization is you can write every composite number as a product of prime factors. This is what's called prime factorization of a number. We use a factor tree, which is a diagram that shows the prime factorization of a composite number. Again, we did this at the beginning of the year, and you should have also had practice with factor trees in your previous grade levels in 3rd and 4th. And then a reminder about composite numbers and prime numbers. A composite number is a number that can be broken down. For example, the number 6. 6 can be broken down into 2 times 3, making it a composite number because it can be broken down. However, a prime number is a number that cannot be broken down. So 7 is an example of a prime number because nothing other than 1 and 7 multiply together to get 7, which is what makes it a prime number. Nothing else can multiply together to get it except for 1 and the number. Okay, so our first example that we have here is Mr. Dempsey surveyed his class and found that his students have a total of 36 pets. Find the prime factorization of 36. So you guys can see here that we have 2 factor trees set up. So just in case we forgot, there are different ways you can find the prime factorization. 36 can be broken down into a few different ways. It doesn't matter which way you choose to break it down when you start off. The important thing is that you get it all the way broken down because no matter how you started off, and we're going to see right here, no matter how you started off, you're still going to end up with the prime factorization that's the same at the end as long as you've done your factor tree correctly. So let's look at these 2 examples. So let's look over here at 2 first. So 36 broken down, they're asking 2 times what gets us that 36? You should know. 18 times 2 gets us 36. So now we know 2 is a prime number. It can't be broken down anymore. So they bring 2 all the way up to the bottom because we still need that 2. But we can break down 18. What times what gives me 18? Well, I know 2 times 9 gets me 18. Okay, and just like they did with the 2, I'm going to bring this down because I am going to need that 2 for my prime factorization, but I can't break up the 2. 9, however, is a composite number, so it can be broken down into 3 times 3. Okay, so here's my prime factorization right there for 36. Now we're going to go over here and look at 3 times what gets us 36. And if we do it correctly, we should get 2, 2, 3, and 3. It might not be in the same order, but we should still get that prime factorization that we see there. So now we got to think 3 times what gets us 36. I know it's 12. Okay, and then I got to think to myself, what times what gives me 12? And you can see just like the 2, they brought the 3 all the way down because that's a composite number. We can't break that down. I mean, a prime number, sorry. They can't break that down anymore, so they brought it down because we still need it for our prime factorization. Okay, so 12. We can break apart into 2 times 6, 2 being a prime number, and bring that down. So that's a part of my prime factorization. And the last thing I need to do is break apart 6. What 2 numbers can I multiply together to get 6? I know it's 2 times 3. So if I compare my prime factorizations here, I have 2 2s. Yep, and over here I have 2 2s, and then I have 2 3s. Same on the other side. So no matter which way you break it down, you're still going to get the same prime factorization. And you can see right here, this last step right here says we need to write the prime factors in order from least to greatest. So when we broke it down here, they were not in order. But when we write our final answer, they need to be in order from least to greatest. That's how you properly write your prime factorization. If you just write the numbers all jumbled together, it's not as easy to see. When you have it in order like we have here, that is the proper prime factorization. So least to greatest means we put our 2 2s first, and then we put our 2 3s last. This is the proper way to write your prime factorization. And then real quick, looking at the check, it says work backward, multiply all the factors, prime factors, in order from left to right, and then compare your product. So when you check your prime factorization, boys and girls, If you multiply all these numbers back together, you should end up with your original number of 36. So let's look. 2 times 2 would give me 4. And then my 3 times 3 would give me 9. Well, ask myself, 4 times 9 gives me what? It gives me 36, which is what my original number was, which means I'm good. That is my proper prime factorization there. So let's look at another example. Okay, example 2. So this one simply says, find the prime factorization of 24. And we're only going to do it one way on this one, but just like I showed you on the last one, it doesn't matter which way you break it down, as long as you break it down all the way to prime numbers, so you get that prime factorization, doesn't matter how you start. And look at over here on the side, it says you can choose any pair of whole numbers such as 3 times 8, 4 times 6, or 2 times 12. All of those multiply together to get 24. In this case, we're starting with 3 times 8. We know 3 is prime, so it's just going to be brought straight down into our prime factorization there because we can't break it down. But we can break down 8. Think to yourself, what times what gets me 8? Well, I know it's 2 times 4. My prime 2 I'm going to bring down. And my last thing I can break apart is 4. My composite 4 breaks down into 2 times 2. Now, there is a problem with this. I'm wondering if you guys can think at home, what is the problem with how this is written? I cannot pull that right over here and write it like that, and it says it right here in step 3. Write the prime factors in order from what, boys and girls? Least to greatest. Right now, it's ordered from greatest to least. So I want to switch that around. I'm going to put all my 2's first, and then I'm going to end it with my greatest factor, which is 3. And again, the check down below says we multiply all our numbers. 2 times 2 would give me 4. 2 times 3 would give me 6. If I multiply those together, I end up with 24, which was my original number. So that check shows me that I did do my prime factors correctly, and my check is good. Okay, and just like I said before, and it says here, you can start with any 2 numbers as long as they multiply together to get that number, and you should still end up with the same prime factorization if you break it down correctly. Okay, another example here. We're going to break down and find the prime factorization of 16. So they're starting us off with 2 times something gets us 16. We should know 2 times 8 gets us 16. You can see again that they can't break down the 2. That's a prime number, so they brought it straight down to our prime factorization there. But I got to think to myself, what times what gets me 8? Well, we just did that on the last one. We know it's 2 times 4. This looks very familiar to our example 2. We're going to bring down this 2. 4 can break apart into 2 times 2. Now, this one's a little bit different, and you might notice they're all 2's on this one. So I really can't put them in order because they're all 2's. So this one, simply enough, I just bring down all my 2's. If I wanted to check it, I could ask myself, okay, 2 times 2 is 4. These 2 times 2's are 4, and then 4 times 4 would give me that original 16. So I know my prime factorization is correct on this one as well. Okay, we're going to look at a couple more examples, and then you'll be able to do your reteach lesson and your iReady lesson as well. Okay, so the first problem we're going to do is 63. So I am going to write 63 right here. And boys and girls, when you do these problems, you need to make sure you show your factor tree. Don't just try to do it in your head. You may miss something. The factor tree is essential for you to be able to break it down and see what you are breaking down. What are those prime and composite numbers you're using? Okay, so the first one here is 63. I got to think to myself, what times what gets me 63? I know that 7 times 9 gets me that 63 I need. So now I need to look. 7. Is 7 a composite number or a prime number? Well, it's actually a prime number, which means I can't break it down. So I'm going to end up bringing that 7 down. But 9 is a composite number, so I know it can be broken down into 3 times 3. Sorry, it's getting a little sloppy. I'm going to bring my 7 down because 7 is a prime number. And the only thing I need to fix here is that I need to put them in order from what, boys and girls? Least to greatest. So I need to put 3 times 3 first, and then I can put my greater number of 7. So this is how I show my prime factorization. I put all the numbers multiplied across in order from least to greatest. Okay, let's do 18. And I'm actually going to use it up here so I can save space. So what are we going to break 18 into? We can do a couple different things. You could do 18 is 9 times 2, or think to yourself, what's another thing I can break down 18? So let's do 9 times 2 first. 9 times 2 gives me 18. What's another? Actually, let's focus on this one first. So what breaks down 9? 3 times 3, and we know from our examples that 2 is a prime, so it is simply brought down. And the only thing we need to make sure we do is put them in order from least to greatest. I'm going to do 2 first, and then my 2 3s afterwards. There's my prime factorization. And then just to check, let's do a different one just to see that we get the same one. So another 2 numbers I can multiply together to get 18 would be 6 times 3. Okay, I know 3 is a prime number, so 3 is brought down, but I can break apart 6 into 2 times 3. And if I check that with my answer, I can see right there that I get the exact same number. So again, it doesn't matter what 2 factors you start with, as long as they do multiply to that factor at the top, and then break it down until you have nothing but prime numbers at the bottom. You can't break it down anymore, and that is your prime factorization there. Okay, we have 2 more examples here. So we have 40. There's quite a few ways you can break down 40. I'm going to go with 4 times 10. And then I'm going to break down, both of these numbers can actually break down. They are both composite numbers. So 4, I know, is 2 times 2. And then 10, I know, is 2 times 5. And it just so happens that the way I wrote it, it is already in order from least to greatest. So I'm just going to take it and put it up on my line. All of these are prime numbers, which means they cannot be broken down anymore. And these, or this right here, is my prime factorization of 40. 2 times 2 times 2 times 5. Again, just like we practiced in our examples, if you wanted to check, 2 times 2, gives me that 4. 2 times 5 gives me the 10. And if I multiply those back together, I get the 40 that I started with. So there's my check right there. If you ever want to check to make sure your prime factorization is correct, I can see right there, that prime factorization does come out and still equal my 40 that I started with. Okay, boys and girls, last example we're going to do. 75. Whenever I think of 25, 50, 75, 100, I always think of money and I think of quarters. So I think to myself, how many quarters does it take to get to 75? I need 3 quarters to get to 75. So I know 3 quarters, and I know 25 cents is 1 quarter. So I'm going to break it down. 3 times 25. You don't have to break 75 down like that. There's a few ways you can do it. I know 75 is divisible by 5, so it's going to be 5 times another number. Okay? And then I know 25 breaks down into 5 times 5. Now, boys and girls, sometimes I've seen this at the beginning of the year, some of you make mistake of forgetting to bring down one of your factors. You get down here, you're like, okay, it's 5 times 5. But if I were to check, 5 times 5 doesn't equal 75, that only equals 25. So make sure you bring down all your prime numbers, otherwise you do not have the correct prime factorization there. And I already have it listed in order from least to greatest, so I'm just gonna bring it up. 3 times 5 times 5, and that will come out to be my 75 that I needed. Okay, so we did a few examples there. Now let's look. Okay, so your assignments for this review lesson are to do the reteach page and then your iReady lessons. Just a reminder, if you go on Prodigy, you're not going to have specific teacher assigned lessons. The questions that your teacher assigned you will pop up in the game while you're playing it. So your battles and everything you do in Prodigy will have questions similar. So you may see some prime factorization or some other types of review lessons on Prodigy, so look out for those. And otherwise, we'll see you for the next lesson.